Here next topic is electronegativity. Simply it is called En. Before discussing the definition of En, I will discuss one point, that is, see, AB. Let us assume this is a molecule. Let us assume between A and B covalent bond is there. This line indicates covalent bond. This bond contains 2 electrons. We will discuss again about covalent bond in next chapter, that is chemical bonding chapter. So before forming bond, A contains 1 unpaired electron, B contains 1 unpaired electron. When these two atoms shares these 2 unpaired electrons, then one bond will be formed between A and B. Then that means sharing of electrons takes place between 2 atoms. That is called what? Covalent bond. So this bond contains 2 electrons. After forming bond, these 2 electrons belongs to either A as well as B. So what is the point here? If A is having more electronegativity compared to B, then what happens? These 2 electrons, that means these paired electrons, moves towards A atom because A is having more electronegativity. Suppose if B is having more electronegativity, then these 2 electrons readily moves towards B atom compared to A. That means, what is the definition of electronegativity? Here, what is the definition? The tendency of an atom to gain shared pair of electrons by itself is called electronegativity. So what is the definition? The tendency of an atom to gain shared pair of electrons by itself is called electronegativity. It is a relative property. Relative property means it depends on other atom. See, here both are different atoms. Suppose if that means if 2 same atoms are present, in such cases En is 0 because both are having same strength, so that these 2 electrons cannot move towards either of the atom. But in this case, electrons definitely moves towards either A or B. That depends on electronegativity. That means that is relative property. That means it depends on other atom. That is why it is called relative property. Next, it has no dimensions. No dimensions means it has no units. Next, this electronegativity can be calculated by 2 scales. They are mulligan scale and Pauling scale. According to mulligan scale, electronegativity is the average of IP and EA. That means IP plus EA by 2 is nothing but electronegativity. This is general expression. Sometimes IP expressed in electron volts per atom and EA also expressed in electron volts per atom. In such cases, we have to use this formula to calculate electronegativity. Electronegativity is equal to IP plus EA by 5.9 when these are present in electron volts per atom. Suppose when these dimensions are present in kilocalories per mole, then we should use this formula to calculate En. When these dimensions, these values present in kilojoules per mole, then we should use this formula to calculate En. So all this is all about calculation of En according to mulligan scale. Next point. According to Pauling scale, this is the formula to calculate electronegativity. Xa minus Xb is equal to 0.208 root delta kilojoules per mole. That means this is the formula according to Pauling to calculate electronegativity of an atom, where delta is what? Bond energy. Suppose, how to calculate bond energy? See, this is covalent bond. To break this bond, we need some energy. That energy is called bond energy. So by using that bond energy, we can calculate electronegativity according to Pauling. According to this Pauling, hydrogen is reference element. Its En is 2.1. That means reference element means by using hydrogen we can calculate electronegativity of any element. Suppose I want electronegativity of chlorine. What should I do regarding to this theory? That means I should react that chlorine with hydrogen. Then we get 2HCl. Between hydrogen and chlorine, covalent bond is present. So this is covalent bond. To break this bond, we need some energy. That means that is called bond energy. So that bond, if you know that bond energy, if you substitute that formula and that value in this equation, then we can get electronegativity of chlorine by using hydrogen. So like that we can calculate electronegativity of any element by using hydrogen. So according to Pauling, hydrogen is a reference element. Its En value is how much? 2.1. Next, variation of En in groups. Variation of En in groups. So in groups from top to bottom, electronegativity value decreases due to increase in atomic size. In groups from top to bottom, En value decreases due to increase in atomic size. That means what? If atom size increases, it is very difficult to gain the electron. But if the atom size is very less, it easily gains electron. It easily gains electron from other atom. So what is the point here? If atomic size increases, En decreases. If atomic size increases, if atomic size decreases, En increases. So what is the point? In groups from top to bottom, En value decreases due to increase in atomic size. Both are having inverse relation, just like IUPAC. In periods from left to right, En value increases due to decrease in atomic size. I told you already, if atomic size decreases, En value increases. Why? If size of the atom is less, it readily gains electrons from other atom. Next, highest En of element in periodic table is fluorine. See, this is all periodic properties. Atomic size IUPAC En. So except atomic size, all are decreases in groups. Except atomic size, all are increases in periods. Next, last topic here, that is IUPAC name of elements with Z greater than 100. IUPAC name of elements with Z greater than 100. That means if atomic number is more than 100, we should follow these rules to call name of the element. See, if 0 is present, then that is called nil. If 1 is present, that is called un. If 2 is present, that is called bi. If 3 is present, that is called tri. 4 is present, that is called quad. 5 is present, pent. 6 is hex. 7 sept. 8 oct. 9 n. AENNN. For example, 115. That means 1 means what? Un. Again 1 means un. 5 means pent. Last word we should add IUM. In every element we should add IUM. That means unpentium. This is short notation, UUP. One more example, 101. 0 means nil. Again 1 means un. IUM. In case of 102, un, nil, BI. No need to add one more I. Here already last letter I, so that you can add UM. So unil BIUM. This is short notation, UNB. So like that we can write any element after atomic number 100 according to IUPAC. So this is all about classification of elements. Thank you.